Okay, I'm going to give this question a go. I must confess, I did this question the other day and I got a different answer to the one that's in the mark scheme. And I have checked my working over and over again and I can't quite see where I've gone wrong. So I also think that the mark scheme itself doesn't make any sense. So I'm going to present what I've done, and if anyone can find any mistakes that I've made, I will be very appreciative. So, the question is, let f of x equal this equation here, and for each real number a, let m of a be the greatest value of f of x in this interval. So, let me just... 3ax squared minus 6x cubed, and m of a is equal to the maximum in this interval. Sorry if you can hear the wind whistling past my window. We get a lot of wind in Wiltshire. It's the maximum of f of x, like this. And it wants us to determine MA when A is greater than 0. And the formula, it says we need to identify 3 ranges. So I'll show you, I identify 2 ranges. I can't quite figure out how given the answers, they turn this into 3 ranges, but we'll see. So let's think about, for a second, before we start this question properly, let's think about what we're going to do. We have a function, f of x, and we have these sorts of boundaries. Let me do it with dotted lines, actually. So we've got this boundary 1 here, and we have another boundary negative a third here. Negative a third. And we have a function, so the function could be something like this. It could be something like this. It could be something like this. We've no idea. But when we think about the places where the function can be greatest, it can either be greatest on the minus a third line, so it could be something like this. It could be greatest on the 1, so it could be something like this. Or it could be greatest at some intermediate value in the middle, like this. Okay. So what we have to do is we have to consider those three those 3 places. So let's figure out what f of 1 is in terms of a. F of 1 is equal to 3a minus 6. Okay, that was pretty easy. F of negative a third is equal to 3a minus a third squared minus 6 minus a third cubed, which is a over 3 minus, plus 6 over 20, I'll say 3 cubed. So 6 is 2 times 3, so I can cancel one of those. So I've got a over 3 plus 2 over 9. So I'm going to make that equal to a 9th 3a plus 2. Okay, so now we have f of 1 and f of minus a third. And we can ask the question, when is f of 1 greater than f of minus a third? Natural question to ask, right? This is true when 3a minus 6 is greater than a 9th 3a plus 2. So if we just solve this, we get 27a minus 54 is bigger than 3a plus 2. Move that over, so 24a is greater than 56. A is greater than 56 over 24, which is 28 over 12. Which is divided by, I'll just halve it again, 14 over 6, 7 over 3. So when a is greater than 7 over 3, so let me make this statement plain. F of 1 is greater than f of minus a third, when a is greater than 7 on 3. Right? Okay, but there's also another possibility, which is that the highest value is somewhere in the middle. So how do we find this? Well, we are going to differentiate f and set the gradient to 0. So f dash of x, is equal to 6ax minus 18a x squared. And this is 0 when divided through by 6, 8x minus 3x squared, x a minus 3x. So when x equals 0 or x equals a over 3. Okay, so there's two possible places where the function has a turning point. There's one here and there's one somewhere else, but we don't know at the moment whether this one's the maximum. We don't know which one the maximum is, right? It could be 0, it could be a over 3. So how do we figure that out? We could differentiate it again, second time, to get 6a minus 36x. Okay, so when we have x is equal to 0, f dash of 0 is 6a, which is greater than 0. So f of 0 is a minimum. And when x, equals a over 3, f dash of a on 3 is, I don't know why I've written is, is equal to 6a minus 12a, which is negative 6a. So f of a over 3 is a maximum. Okay, so we never need to worry about the minimum. We only need to care about the maximum. F of a over 3. So let's figure out what f of a over 3 is. A over 3 is equal to 3ax squared. So 3a over 3 squared minus 6a over 3 cubed. So we have 3a times a squared on 9 minus 6a cubed on 27. So a cubed on 3 minus 2a cubed on 9. So make that 3 on 9. Final answer is a cubed on 9. So f of a over 3 is equal to a cubed on 9. Okay. So let's do what we did before. Let's ask the question, when is f of a over 3 greater than, say, f of minus a third? F of minus a third. That is when a cubed on 9 is greater than f of minus a third. What was f of minus a third? I've forgotten. There it is. A ninth, 3a plus 2. A ninth, 3a plus 2. So cancel the 9s. A cubed is greater than 3a plus 2. It is when a cubed minus 3a minus 2 is greater than 0. So let's think of a factor of this. Is 1 a factor? No, negative 1. I think negative 1 is a factor. So if I do a plus 1, we've got a squared, and I've had a, this gives a cubed, so I've added a squared, so I need to take away an a squared, so take away a, so I have to take away 2. So factor of this, I think minus 1 again? Yeah, minus 1 again. So a plus 1 squared. And then it must be a minus 2. So f of a over 3 is greater than f of a third when a is bigger than 2, which is this condition here. Okay, and the next question we need to ask is, so let me zoom out a little bit. So we now know that we've got this one condition. Let me draw them in coloured boxes. We've got the red condition, which is here. And we've now just figured out the green condition, which is here. So the next question is, when is f of a over 3 greater than f of 1? That's our last condition. So when is f of a over 3 greater than f of 1? Well, f of a over 3 was a cubed on 9, so f of 1 was 3a minus 6, wasn't it? 3a minus 6. So when is this true? Times both sides by 9, a cubed is bigger than 27a minus 54. So that gives us a cubed minus 27a plus 54 is bigger than 0. Right, let's find a factor of this. 2. Does 2 work? No, because 2 cancels those. 1 doesn't, so it could be 3? 27 minus 2. Yeah, I think 3 works. So we've got a minus 3, must be a factor. Right, so that gives us a cubed minus 3a squared, so we need a plus 3a to cancel those, which gives us minus 9a, but we need minus 27. So if we take away another 18, yeah, that works. And we need another factor of this. 3 again, I think. A minus 3 squared. So it must be a 3 squared is 9. What do we need to get to 54? 6a plus 6 greater than 0. Right, so when is this true? This is actually true for all values of a, right? Because this is always positive and a is bigger than 0. So f of a over 3 is always bigger than f of 1 for all a. So I'll draw a box around this one, blue condition. Okay, and now we can zoom out and we can see our 3 conditions here. Now what we need to do is figure out, we can basically say what m of a is now, right? We can say that m of a is equal to, what are our cutoff points? when a is less than, so when a is, we know a has to be greater than 0, less than 2. The biggest one is f of a third. Right? Because f of a over 3 is bigger than f of a third when a is bigger than 2. So when a is less than 2, f of a third is bigger. So this is f of a third. And we can check that f of a third, sorry, minus a third. Ah, crap. This should have been minus a third here. Sorry, I put minus a third here. I just didn't write it in there. So it's minus a third. Yeah, again, it doesn't change anything. So a is, when it's between 0 and 2, it is less. So in this case, f of minus a third is bigger in both cases. Okay, what about when a is bigger than 2? Well, here is where I get my disagreement with the mark scheme, because when a is bigger than 2, we have this one is true, right? A over 3 is bigger than, f of a over 3 is bigger than f of minus a third, so it cannot be f of minus a third. And we also know that f of a over 3 is bigger than f of 1 for all a, so it should be f of a over 3, right? And that's it. I can't see any other condition. So the mark scheme actually has these 3 conditions the same as what I figured out here. And I agreed with the mark scheme on those 3. But the mark scheme seems to think that when, so I'll do the mark scheme answer in a different colour. So what they say, they agree with the first bit. So they agree with this. However, they agree with this bit. This is between 2 and 3. But then they say this. So when a is bigger than 3, they have this third condition here. I don't understand why they've done that. So I would be very appreciative if someone else, if someone else figures out where the logic's gone wrong. I mean, it might be a mistake in the mark scheme. It's a possibility. It seems unlikely, though, given that in the very question it actually asks you to find the 3 different regions. So if I was answering this in an exam, I would have found these 2 regions, and I mean, I'd assume that I must have got the answer wrong. So yeah, I'd be grateful to if anyone could figure out where I went wrong here. Okay, thank you. Okay, I'm back. I figured it out. Literally, as I just closed this down, I figured out the answer. So we'll see now. It's quite obvious, really. I'll do it in green down here. So here is the solution. When a is bigger than 3, the turning point is bigger than 1. So if we go back to our diagram, get rid of these lines here. The turning point, we've got a minimum here. Minimum there. So the turning point is like outside the range that we want. So if the turning point's outside the range that we want, this one must be bigger. Does that make sense? F of 1 must be bigger, because we've got this condition here. So the mark scheme is correct, and I just couldn't see it. So actually this is when a is between that and 3, and f of 1 when a is bigger than or equal to 3. There you go. Do you see that? Does that make sense? So it would have been what I said before, except for the fact that that a of 3 is only a turning point that we're interested in if it's in the range minus a third to 1, right? Because we're only interested in turning points that are inside of the range of x values. We don't really care about we don't care about the ones that are outside. If the turning point's on the outside, then the maximum must be either end of the range, either 1 or negative a third. Okay, so sorry for confusing you there, but I think it's clear now. It often happens that as soon as you stop thinking about the problem, the answer just appears to you, and that was one of the cases here. Okay, hope you enjoyed that one.